Are you guys ready to start another class? So we are about, let me check, 25 participants. So we're about to start. So let me share my screen with you. Or you know what? I have received a couple of homeworks and they had some questions about it. So let's start. Let me share my screen and then we'll go through those. Share screen. Okay, so remember about our homework that we decided that we're gonna make a frequency distribution table and a histogram. And you are gonna ask all your ages on your family. That way, so we had step one that was dividing, kind of like step one was separate the number in classes. We decided we were gonna start dividing into 8 groups. And step two, we're gonna get our class width, and step three, with our class width, we're gonna start like a lower class limit and then our upper class limit. And step four, getting our class boundaries and class midpoints. Let's see. Did anyone I got a couple of questions that I'm gonna answer. And let me see. So I decided that I should also make a little homework. And happy 4th of July weekend. So we got, these are my data that I got. Please let me know if you're able to see it or.
I can see it.
Okay, cool. So we got 55, 68, 64, 37, 22, 3, 2, 19, 36, 55, 30, 80, 62. So these are all my data points. I got 32. So the step one, we already got it, which was 8 classes. And then step two was getting our class width. Can someone tell me how do we got our class width? This was kind of like one of the most important steps. I'll wait. Or, so I'll wait just a couple of minutes if someone can tell me the formula for it. Yes, very good. So it's the maximum value minus the minimum value divided in the number of classes. So the number of classes was 8. So we're gonna divide by 8. So what's our maximum value? I got my grandparents, they were 82. And then the minimum, probably we got 2, 2, and 2, which my daughter is 2. So we'll stick 82 minus 2. How much is it? 8b divided by 8. So that's easy. Like our class width for me was 10. Yes, perfect. So what will be our step 3? So step 3 will be, we'll initialize with our upper class limit and a lower class limit. So what do I mean by, do you remember what do I mean by lower class limit? What is a class or a group? So I don't know if you guys remember, but we got this are called classes or groups. So remember with the Fruit Loops, the groups was kind of like the red or the green or the purple. So in this case, that the ages will be our classes. So we'll go over. So step 3, we're gonna start with our first class, lower class limit. So we got here that our lower class limit is 2. So we start with a 2. And then this is gonna be a tricky question. How do we use our class width? So our 10, so the 10 will be 2 plus 10, or it will be, so 2 plus 10 will be 12. Where should I put the 12? Over here or down here? For the next class, very good. So, and then plus our class width that is 10. So we got 22 plus 10, 32, plus 10, 42, plus 10, 52, plus 10, 62, plus 10, 72, plus 10, 82. So here I got my 2, 4, 6, 8, 9. And the class width, this is data, and you can always cut it. Whenever you cut, I was telling you a quick example. Whenever you cut a piece of bread, like if you make one cut, you're gonna get one extra slice. So you're always gonna get one extra slice, and you can keep cutting. You can keep cutting, and it's okay if you, like for example, on this one, where there's gonna be more information. We don't have frequency for that one, but there is information here. So below the 2, if we subtract the width, it'll be 10 minus 2 minus 10 will be minus 8. But since we're talking about ages, we cannot be minus, it cannot be negative. So here we're gonna have another class that's 0 to 2. Okay, so can someone tell me what will be the number here? So what would be our upper class limit? $11, very good. Why 11? So we started with 2 and our width is 10. So we started with 2, 3, 4, 5, 6, 7, 8, 9, well, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's why, so it's our width is 11. If we had 12, then we're counting for the 12, but the 12 is the next category. So it's, so what's, this is called our first class. Lower class limit, upper class limit, and it's also called the range. So the range for the class limit, I have it here. So the range for the class, first class limit will be from 2 to 1, right? But our range for the whole data, it's gonna be from 2 to 82. So the range is the 82 to 2. So our range is just the maximum value and then the minimum value of a data set. So this is called the range. Okay, so let's continue. So a quick tip is also adding 10. So that my next number will be plus 10. 21, 31, 41, 51, 61, oh no, 71, 81, 91. And then our frequency, I think I have already the frequency. So let me just write it down. So I got 6, 5, 3, oh shit, 5, 2, 4, 3, 3, and 1. remember what was midpoints and boundaries? A quick difference, the boundaries was only to make a histogram. Because a histogram is it's a chart, a visual chart, but with, it's kind of like a bar graph, but without the separation of the lines, and everything has to get to 100. How did I get the frequency? Like I start counting this one. So from 2 to 11, I got 6. So it's 1, 2, 3, 4, 5, 2 to 11. 1, 2, 3, 4, 5, 6, and then 6. Well, there was another one. So there should be 1, 2, 7, right? And then from 12 to 21, 12 to 21, I go 1, 2, 3, 4, 5, 5. And then from 22 to 31, I go 1. It's just how much data points I got of that class. So that's how I got this one. But I'm thinking from 2 to 11, 1, 2, 3, 4, 5, 6, 7. I think I got 7, not 6. Thank you. So that's our frequency. Like frequency is how many times we got, like if it was for the Fruit Loops, if it was the frequency, if we got 11 blue Fruit Loops on our sample, our frequency will be 11 Fruit Loops of our blue. Or if we got 5 of the red ones, our frequency will be 5 of those red ones, but for our sample. So this is my sample. And I want you to notice that every data set, I have it as an X. So X28, X29, X30, X27, X18. You see it? Yeah. So, okay, coming back to the question on the midpoint, how do we get the midpoint of this class? Yeah, very good. So we got the upper class limit, which is 11, plus the lower class limit, which is 2, divided by 2. So 11 plus 2, that's 13, divided by 2, 6.5. Okay, get your calculators out because I'm gonna need some help. So what will be 12 plus 21 divided by 2? 12 plus 21, that's 33, divided by 2. 16.5, very good. And then the next one, 22 plus 31 divided by 2. It's half, so it's half of the class. So yes, so the midpoint, yeah, that's exactly what it is. The midpoint is the half between these two classes. So I will be here. (22 plus 26.5). Do you see a trend here? So it's 6.5 plus 10, 16.5 plus 10. So it's our same class width that is over here, that it's 10. So the midpoint will be 36.5, 46.5, 56.5, 66.5, 76.5, and 86.5. And remember, whenever you have your class width, if it's right here, I got lucky. I didn't do it on purpose. but I got a whole number, which is 10. Well, usually you're gonna get a decimal point, like 2.5, 2.34, 6.5, but you always gonna wanna round up. So if it's 6.5, you round up to 7. Over here, we have a whole, so it's 10. Okay, so can someone add 7 plus 5 plus 3 plus 5 plus 2 plus 4 plus 3 plus 3 plus 1? That's 33. Very good. So I got, let me put it with another color. Let's use red. So I got 33. So what's this? What does this 33 means? What is it? So this 33 is the total. 33. So 33, it's all of these numbers. So 1, 2, 3, 4, 5, 6. So all these numbers are 33 numbers. So 33 data set points. So this should be 33. And this 33, I don't know if you remember. Yes, very good. That's our letter N. Little a letter N. Okay. So if we got 33 over here, what will be our relative frequency? So relative frequency means the percentage out of the whole 33%. So over here is 7 divided by 33, 5 divided by 33, 3 divided by 33, 5 divided by 33, 2 divided by 33, 4 divided by 33, 1 divided by 33. So 7 divided by 33, yes. How much is it? I don't have a calculator, so I'll have to wait. 0.212. Very good. And then the next one. Let me put it with another marker, Flo. Very good. 0.151. 0.212. And then the next one. 0.1. 0.09. And then 5. Oh, probably the same as, and then these 2. 0.0. And you always want to round up at least to 3 decimal places. So 2, what about 4? 0.121, and then 3, we got it up here, 0.090, 0.090, and then 1 with 0.03. What about 1 divided by 33? Yeah, got it. Okay, so we could either put it on decimal, or we could convert it like past two digits and put it 21.2%. Or we divide this divided by 100, divided by 100, then we get the percentage. So it's 15.1%, and then 9.0%. So we just move the decimal 2 points because it's divided by 100. So 15.1%, 6.06%, 12.1%, 9%, 9%, and then 3%. So if we add this one, it should be very close to 100. So 21 plus 15 plus 9 plus 15, that's 60 plus 6, 66 plus 7 plus 12, 66, that's 78 plus 9, 88 plus 9, 88 plus 9, 96, 97 plus 3. This will be 100. Very good, guys. And then the class boundaries, we said that's only specifically for a histogram. So we could either use the midpoint or use the class boundaries. So you remember how do we got the class boundaries? Which data do we use? Yeah, very good, 11.5. Let me use the purple marker. So we got 11.5. So we use this one and this one. So we add 12 plus 11 divided by 2, that's 11.5. So remember, very quick, easy, add the width, which is 10, 21.5, 31.5, 41.5, 51.5, 61.5, and 71.5, 81.5, and 91.5. You got any questions on how to build this frequency distribution table? So I expect your homework to be similar to this one. So now we can move on to the next topic, which will be the mean, the median, and the mode. Do you want me to build the histogram, or you guys? So just a quick question that I got on the histogram. So the X, this is your X, and this is your Y. So this will be your frequency. We got a couple of options, or you could graph it different ways. You have your relative frequency. You can build it by percentage. So this could be a percentage. So this could be 100%. So this could be 50%, 20%, 25%. You can go by percent, which you have it here, or you can go by frequency. So you could graph it by frequency or by the percentage. And then your X, so this is your Y. It could be that, or it could be by frequency, which you got 10, 5, 7, 3, 2. And same with your X. You could use the class boundaries, or you can use the midpoints. So if you're gonna, if this is one of your graphs, right? Your midpoint, your midpoint should be here. So you just over here, you put 16.5, and over here you put midpoint 6.5. But if you're gonna use your upper or lower class limit, you do your graph, you do your graph, and then you put them here. Like if this is your upper class limit, you put here 22, and then over here 32. So wherever, but I think it's easier to put on the midpoint, but you can use either or. Okay, so we're ready to, now let me share my screen. And you can always text me or send me a questions. Are you able to see my screen? Good. Good, very good. So let me move this. Okay. So if you have any questions, just send it to me. So today what we're gonna talk about is about data characteristics. the characteristics of the data. It's gonna be hopefully pretty simple. You're pretty smart, and we're gonna talk about 5 characteristics for describing the data. The first ones will be the center, which a lot of people call it mean or average. That'll be what's the center of your data. Of course, we're gonna have some variation between your data. For example, the Fruit Loops, some of them were thicker, some of them were thinner, or the variation of the color. Some blues could have more saturation of blues, or the variation. Remember how we talk about waiting in line for a grocery store, and we talk about having one person kind of having like 3 types of lines, like one having a very long line, and I'm always the very last person that waits like 14 minutes and the first one waits 1 minute, but on average, they wait 6 minutes. Or the person at Target that is kind of like guiding the other persons, that way all of the persons wait the same amount of average, 6 minutes. Or the other cashier that we have like 3 cashiers open, and of course the one that I'm at is always the slowest somehow. So there's a different variation on those data or lines if we start collecting like the time it takes for them to, once they enter the store and once they leave, or the register. The distribution, we're gonna also talk about some outliers and some how some outliers can affect your data, and changes over time, or if you could start seeing like a trend. If your mean is going up or if your average is going down, you will see, you can catch a trend. That's why you don't want to have like too many groups, too many few groups, or too many groups, because that way you're gonna catch your trend. So the first one that we're gonna talk about is the center. So as I told you before, this is called the average for most people. It's pretty it's pretty common to say average or the mean, which the meaning is the arithmetic average. And a quick example that I thought is kind of like your classes. So whenever you get, it's in Spanish, I couldn't find, I guess over here they do more like grades. I don't know if you guys do like grades like this, or you go do more like A, B, C, or A+. So I put an example of the classes that you got, and then the average that you get at the end of the semester. So it's averaging your semesters or your months or your classes. So can someone tell me what would be quick, or how do you guys average the mean? Yes. So usually what we do is we add all of the values and then divide it by the number of values you added. So in this case, if you got 1, 2, 3, 4, 5, 6 classes, you add all those classes up and then divide it into 6 classes. Have you guys seen this symbol before? Like a E, like a Greek E? Yeah, cool. So that symbol stands for addition. So in the mean, we'll be adding all of your x's. Well, your x's will be this, all of your data points. Like you add all of your data points and then divide it by the number of values. And we're gonna have, in statistics, we have 3 ways of measuring the mean. So Ramaya says like, this is addition. So that's correct. So that's the sign for addition. I want you to get familiar with all these Greek letters. That way, whenever we have like big formulas, you exactly know what they mean. Do you remember what's the symbol or the variable for a data value? Very good. It's X. Very good. Very good, Ramaya. It's X. So the mean, we said that it was the sum of all the data values divided by the number of values. And do you remember what was our little letter N? We talk about it over here. So N over here was 33. We added all of our data values. Or for our class, we got 69 students. So our N was 69. So N stands for the, very good, Lucy. So the total of number of values, but for a sample. We got a little letter N, which is the sample of values. Like, remember we talked about having the STEM class as our N, because that was our sample. But our population was the whole Texas or San Antonio students. And the letter big N is our population. But it makes sense, right? Little n for sample, big N for sample. And since we have two divisors or two things that are dividing, we're gonna have two different means. One mean for a sample and one mean for a population. So far, all these four variables, you know what's the meaning now if I ask you? So we got Greek letter E, which stands for sum. We got the X, which that's our all like data values. We got our N, little letter N, which is it's the total of values, number of values for the sample. And then we got our capital letter N, which that's our total values for our population. Usually the population it's really hard to count them all. Usually you deal with sample, but on problems, like on your next classes or whenever you start doing problems, they're gonna give it to you. They're gonna tell you, okay, the total values of the population is this, or they're gonna tell you, and it's this. So if we add all the values and then divide it by the sample, we're gonna get our sample mean, which our sample mean, it's an X and then it has a bar at the top and it's called X bar. I'm not kidding, that's how it's called, it's X bar. So if they tell you X bar, they're talking about the mean of the sample. So whenever they tell you X bar, that's the sample mean. What about the population mean? So you're gonna divide by the total values of the population. This one is pretty cool. That's the total. It's between a U and like an M. So can someone guess what's called? Yes, it's called mu. It's like it's kind of like a weird cow sound that says mew. I'll try to make a cow sound. Huh. Pretty good, right? So, okay, so far these three means, so you're gonna have three means, either for the sample, either for the population, or just a regular mean. Let's put a quick example. So a quick example that I thought, it was like, okay, what about if you have a change in your car and they add up to, one day you had 48 cents, the other day you have 42.73, $1.10, $1.10, and 5.40. Can someone get me the mean that I have for my 6 days? So we're gonna add 540 plus 110 plus 0.48 plus 0.42 plus 0.73 plus 1.10. I'll give you, yeah, very good, 1.538. Oh, wait. I think I had it. Yeah. So I got 9.23 divided by 6, 1.50. Yeah, very good. I think you got it perfect because you have 3 decimal points, which is 1.538, and I only put 1.54. So, very good. So far you have any questions on the mean? So we're gonna could have the mean for the sample, which is bar X, and then we could have the mean of the population. Remember, it's between a U and an M, and it's called mu. And then have you heard median? It's kind of mean, but the median, it's the middle set of the value, the middle data set of the value. Very good. So the mean is the center of the value, and then the median will be the middle part of your data set. So can some, like if we got this data set 0.5, 1, 3, 7, 8, 2, 1, what will be our median or our middle value of this data set? Okay, we got a couple of answers. We got a 5, we got a 7, and a 5. So if we just glance at them, we might say, oh, maybe it's the 7 because it's exactly the value in the middle. But in order to get the median they must be in order. So it's a little bit time consuming. It's easy, but it's a time consuming just to order all the data sets. So for this data set, I have 1, 1, 2, 3, 5, 7, 8. So the middle, the number 3 will be your median. So I just wanted to tell you if you have heard whenever they say, oh, the median value of a home or the median salary of like for a professor, or the median salary of that position. So I want you just to think about that, and then we'll go over. Well, why they do the median and not the mean? Think about that. We'll go over, but just wanted you to start thinking about why people use median instead of mean. Yeah, very good. On this one, it'll be the number 3. Very good, Jacob. So what about if we have an even data set of value? Because this one, an even, so what will be on this data set? What will be the median? 4, very good, Ramaya. And then on this one? So the one at the top, it was even. So it was easy to identify that it's a 4. But what about if we have 2 numbers that they are on the middle? So we add them up and say 4 plus 5, that's 9 divided by 2, that's 4.5. Yeah, you were right, Francesca. Lucy, very good. Thank you, guys. You're being awesome today. So I have a few more examples for you. So on this data value set, what will be the median? We got 1, 2, 3, 4, 5, 6, 7. So it's not an even, it's an odd number. So the first thing that we do is we put them in order. So I have 3, 4, 5, 6, 8, 11, 13. So the median for this one, yeah, very good. Jacob, 6. Median will be 6. What about if I add another number that is 412 or 416. What will the median change if I add one more number? Yes, very good, Lucy. 1, 2, Ramaya says 8, 1, 2, 3, 4, 1, 2, 3, 7. Okay, I got different answers. So in order to get the median for this one, we get the numbers in the middle. So we got 6 and 8. Because we got 1, 2, 3, 4, 5, 6, 7, 8. So it's an even number. So whenever it's even, we got 3. Am I right? 6 plus 8 divided by 2. 7. Very good. Very good, Francesca. Very good, Lucy. So we add the 6 and the 8 and then divide it by 2. What about if we go to the example that I had about the change in your car, or the change in that I have for 6 days. So we said we got the mean, which it was 1.54. What about if we decided, well, what about can someone find the median of this data set point? Very good, 0.915, 0.192. Yeah, very good, I got it. Cool, very good. So we got the median. What about the mean? We said the mean was 1.54 or 1.39, right? Are they pretty close? Not really, but what about if instead of the 540, we got 412? What will it do to the mean? Will it change the mean? Probably yes, because you're taking in consideration. Very good, Ramaya. Yes, it will change the mean because you're taking in consideration that big number. So if we throw that big number, will the median change? What will be our median? Can someone add up these 6 numbers? 0.42, 0.48, 0.73, 1.10, 1.10, and 4.12, and give me the mean and the median? Sixty point 60.17 for our mean. Very good, Ava. And what about our median? 60.18. So our mean increased really big. Increased from, remember we had $1.54 in average for that 6 days. If we put this big number, I'm like, yeah, have that number. But our mean grows to 60. We didn't have an average of $60 every day. So that's not a very good way of approaching. That's why we have the median. So the median is still 915. You see that? So for the median it was 915. Even if I change this 5.40 to 412, the median is still the same. The mean is the one that changed from 1.54 to 60. I don't think I have the 60.18, but it changed, it went up. So that's why the median is important. So this 412, it's called outlier because it's affecting your data. Like it's making your data not telling what it's supposed to do. So those are called outliers. So another example that I thought of an outlier, so will be Bill Gates. So why they use US median household income in 2018 and they don't use mean? I mean, they have that data. They could have said the mean for like an average, it'll be thrown off because Bill Gates makes billions. Me, probably I'll make billions, but in the next future, but right now I'm making thousands. So if you're getting the mean and you're adding thousands and then billions, it's gonna throw off the data. That's why median is important. So that's why they use, as I was telling you, like median household income or median salary for a job or the median value of a house. So that's why median so in summary, the median is not affected by outliers, but the mean is. So now we're gonna talk about mode. So we said that coming back to here, we said that we're gonna talk about mean, that we have 3. So it depends, can someone tell me very quick, what was the mean of the sample? We got sample, and we got population. This one 1, this one 2, and then we got the regular one, that is the sum of x divided by the number of values, correct? And this is called mean. So we got the sample, which the sample was x bar. And the population, can someone tell me? It was, very good, mu. So mu is like a nu and an m. Sorry, I think I didn't write very good. So that's between a u and an m. So the population, we use the letter n, and the sample, we use the little n. So we got sum of the data values and the sample sum of the data values. What about the median? The median was the numbers in the middle. Median, middle. If we got, it could be odd or it could be even. If we got like this number, and then this number, this middle, that's the middle. And then an even, we average x plus x divided by 2. That's the median. And then the mode, we talk about, well, now we're gonna talk about mode. So far, so good, guys. Okay. So the mode is the most common occurring data value in a set. We could have a single mode, bi-mode, multi-mode, or no mode at all. So a single mode will be only one digit. So the most commonly occurring data value, so it will be 1 digit that that repeats itself. A bi-mode will be 2 digits that repeats itself the same amount of time, and a multi-mode will be more than 2 or 3 or 4, and then no mode will be no data that repeats. So as I was doing my research on my family and asking the ages, I realized that I got 3 persons that they were 55, 55. I got 2 72s, but I got 355. Where's my other? So I got 355. I got 2 19s, 19, 19. And I think that's it. So I got 355, 55, 55, 55. And then I got 19, 19, and I got 72, 72. So what will be our mode in this data set? 55, 19, or 72? Will this be a single mode, bi-mode, multi-mode, or no mode? So yeah, so this is gonna be single mode because my 55 is the one that repeats the most, but 55, 55, and 55. So that's our most commonly occurring data value set. Yeah, very good. Very good, Francesca. Single. Lucy, very good. There's 319. Where's the other 19? Oh, yeah. See, it's, oh, very good. Someone's paying attention. I guess me, I was distracted. So we got another 19. So we got 55, 50. Yeah, so this is 19, 19, 19. Because this is 9. So that's bimode. Very good. Very good. Okay. I got another examples, but I think you guys are getting it. Very good. So what will be our mode on this data set? Let me just connect my computer because it's gonna, I'll let you think about that. Yes, very good. Very good. It's 1/10. 1/10. That's our mode. What about this data? What about this example? It's the same 55 that I got. By mode. Very good. Very good. Because we got two numbers, the 27 and the 55. And then if the 88 was, if instead of the 89, we got 88, it'll be multi-mode. What about this one? No mode. Very good. Very good. So that's all I got for today. Let me check with, let me see if Alexis had something to show you guys, but I just want a quick reminder. Tomorrow, we're gonna have our Toyota expert, and I think I'm gonna go through, I don't know if you have seen already the video, but if not, I will see if we can have a quick video of the plant and ask him some questions. He's super shy, so I hope you guys ask questions and we'll get the most out of it tomorrow. And then you will see how Toyota uses statistics to build the empire that they have built. Are there any questions on range, mean, median, mode, the frequency distribution, the homework, the histograms? No? All good? No, ma'am. Thank you very much. And Alexis, do you have something?
No, share? I don't.
Okay. That'll be it, guys. Thank you so much and see you tomorrow.
Bye. See you tomorrow.
Bye. And then the homework, you can just send me a screenshot through the Remind app. I think some of you guys, I already received some homeworks and I give some feedback, but this will count as just as your participation. And at the end of the whole STEM, you're gonna get a certificate that will be pretty cool. So please send me your homeworks and I'll see you guys tomorrow. I'll wait a couple of minutes just in case someone has a question. Thank you.